Hello everyone! In this video lesson, we'll describe with you IP version 6. IP version 6 consists of 128 bits. It has 2 to the power of 128 combinations. It is represented in hexadecimal. It consists of 8 hex texts, or we may say it consists of 8 quartets. Here is an example of IP version 6. In this example we may see with you 8 hextets which are separated by columns. Let me show you how IP version 6 can be simplified. Simplification starts from the left side. You have to look for first 0 in the hextets. For example, in first hextets we have another symbol, not 0, at the first place. That is why first hextet is not simplified. In second hextet you may see here zeros in the row, so you will simplify first 3 zeros. And instead of writing 4 zeros, now in one hextet you are just writing 1 0. In the same way, you are looking for other hextets. In next hextet, we may see 1. Then our hextext is not simplified. In next hextet, we may see here 0. So we are taking off 0 and writing other symbols. Next simplification. And next simplification. Next step of simplification. If you have zeros of hextext in a row, you may simplify them, and instead of writing them separately, you'll just write a double column. This double column can be used only once per IP version 6. The rest part will be same. This is a simplified IP version 6. You may make simplification up to this value. This is IP version 6 address, which is simplified. IP version 6 subnetworking. In this example, we have to make addressing for 3 networks. Network A with 2000 IP addresses, network B with 8000 IP addresses, and network C with 2 addresses. Given network to us will be, so we need to find closest prefix to get B network's 8000 IP addresses. How to find correct prefix? First of all, we may start from that in our network address, in our IP address we have 128 bits. In case when your prefix is 127, then you have 2 to the power of 1 available addresses. If your prefix is 126, then you have 2 to the power of 2 available addresses, and so on. Alright, we found with you that prefix 115 will give us 8192 useful IP version 6 addresses. Our first network is going to be 2000, and at the end we will have with you hextet which consists of zeros. Each 0 in this example has 4 bits. Now we found with you that in one hextet there are 16 bits. We have to find where is division between network address and host portions. We have to find 115th bit, or From the other side, we may find rest 13 bits. 4, 8, 12, and division will be happening right here. This is our network address. The last useful address in this network will be equal to this value in hexadecimal. Next network address of network B, next network address of network A will be its binary value will be equal to this value. Now we need to find prefix which will satisfy requirements of network A. Prefix is chosen 117. We have to count 11 bit from right side. 4, 8, and 11. So let us take and mark division between network and host portions. The last combination in this network will be this value, which will be equal to hexadecimal value. Next, we have to find network address of network C. It will be equal to this value. Now we need to represent 2800 hexadecimal value into the binary, and we need to find prefix which will satisfy requirements of network C, which need to have only 2 available host addresses. 2 available host addresses are satisfied by prefix 107. So division of network portion and host portion will be right here. This is our network address. Let us find what will be equal to our last useful address. Let us convert it into the hexadecimal. Well, we made up subnetworking of given network into 3 subnetworks: subnetwork A, subnetwork B, and subnetwork C, with given to us requirements.